We're given a differential equation, an initial condition, and a solution candidate, and we're asked to determine if the given function y equal f of x is indeed a solution of the accompanying differential equation. So what we're going to do, what I'm going to first recommend to do is let's just check the initial condition, see if it satisfies the solution candidate, and that is to plug in this 0 right in here and right in here. All right, and it really doesn't matter what e to the negative 7 times 0 is. I mean, in this case, e to the 0 is 1, but the 7 times 0 is 0, so it yields 0. So the initial condition is met by the solution candidate. So I won't do that at the end. All right, just know that that checks off. Okay, but what we need to do is check, does the solution candidate work for the differential equation? And the only way to figure that out is to take the derivative of it. So what we're going to do is we're going to find our y prime, if you will, by taking the derivative of 7x times e to the negative 7x. And in this case, that is a case of the product rule, u v prime and v u prime. All right, so what do we get? U v prime. We have 7x, okay, e to the negative 7x. So we're going to multiply it by negative 7e to the negative 7x, okay, u v prime, all right, plus v u prime. So e to the negative 7x times 7, okay, and what we get there when we combine all of this is a negative 49 e to the negative 7x, let's see, plus 7e to the negative 7x. And it's actually, I made a little mistake there. It's negative 49x e to the negative 7x. There we go. All right. So now that I've got that, what I need to do is I need to check, does this match? Does this derivative match the differential equation? And so what we're going to do is we're going to check y prime based on what they've told us. And that is that it should be e to the negative 7x minus 7 times y. So y being 7x e to the negative 7x. And then we're going to check that it matches. So let's just do the simple multiplication here. E to the negative 7x minus 49x e to the negative 7x. And now we're going to check. I'm going to use my highlighters here. So negative 49x e to the negative 7x, I have that right there. I have that right there. And then what I have is a 7 e to the negative 7x. Okay. Now that 7 is what seems to be missing. Okay. So notice there is a 7 here, and I'm going to highlight it in purple, that is not visible here, that's not there. So the question is, was the differential equation, or was the function rather, a solution to the differential equation? And the answer is no, it is not a solution. It is not a solution. So this is a prime example of where it is not the case. But let's take a look at another example and see if it is actually satisfied. So let's take a look at that one. Okay, the following example is slightly more complicated than the last in that the differential equation that they give us is a little more complicated. So we're going to first check the initial condition, y of pi equals 0. And so when I plug in pi into y, I get sine of pi over 6 pi. Well, the 6 pi in the denominator is just 6 pi, but the sine of pi is indeed 0. So 0 divided by 6 pi is 0. So the initial condition is in fact met. Okay, that does work. Now what we need to do is take the derivative and then use that and fill it into the differential equation and see if that works out. If it does, then we're in business. This works. The function is a solution to the differential equation, and that's what we're going to verify. So let's first find y prime. Okay. All right. Now that we've got it, we've got to take the quotient rule in this case. So this is high and this is low. And as we say, I always write out high and then d high, of course, and then low and d low. All right. High was sine of x, and so d high, the derivative of the top, or the numerator, is cosine. Low, which is the denominator, is 6x, and d low, the derivative of the bottom, or the numerator, or denominator rather, is just 6. So low d high. We would say, in this case, 6x cosine x minus high d low, which is sine x multiplied by 6, all over low low, which is the denominator, squared, 6x quantity squared. And so I'm going to leave it like that for right now. And there's really not much more to clean up here. So now let's kind of simplify. 6x cosine x minus 6 sine x over 36x squared. You could factor out the 6 here. You could reduce it by a factor of 6, but I think it's okay at this point. Actually, no, let's go ahead and do it. I think I'm just kind of looking ahead here. If I factor out the 6, I'm going to have x cosine of x minus sine x, just like that. And then I'm going to divide that by 36x squared, and what ends up happening is you end up eliminating 6 out of 36, and it becomes 1 over 6. Okay, so there's our derivative, which is going to be x cosine x minus sine x, all divided by 6x squared. This is our value for y prime, and we're going to check if everything checks out. Does this work for my differential equation? So let's check this out. We are told that for the differential equation to work, 6x should get multiplied by y prime. And so what we're going to do is multiply it by x cosine x minus the sine x, all divided by 6x squared right there. And then we're going to add 6 times y, which is the sine of x over 6x, just like that. And then we should set this equal to the cosine of x. Okay, so what do we have here? We have 6x, and we can combine like terms. There's a few things that we can do. There are a few things that we can do. So I think it's probably just best to kind of do this little distribution bit here. I'm going to get 6x squared cosine x minus 6x sine x over 6x squared plus 6 sine x over 6x, and we again set it equal to cosine. So what we need to do is verify that the left side of the equation equals the right side of the equation. And let's see here. Once I do that, I need a common denominator, so I'm going to have to actually multiply this side by x over x in order to combine these two fractions, if you will. And so when I do that, I get 6x squared. So the left side here of the left side, the left of the left side, doesn't get touched, okay? But the right side of the left side does. We end up with adding 6x sine x, and all of this will get divided by 6x squared. So you should start seeing what's going on here. All right, and again, it does need to equal cosine. So you should start seeing again what's going on here. The negative 6x sine x ends up canceling itself out with this positive 6x sine x. The 6x squared again eliminates through division. And we are left with the statement that the cosine of x equals the cosine of x, which checks off on both sides. So this seems to work. Everything looks good. All right. Going back to what it is that we were asked, is the solution candidate a solution for the differential equation? And we have verified that through this process. So yes, indeed, it is a solution. And we verified the initial condition at the very beginning as well. So as always, I hope this video was helpful. And remember, like and subscribe.